In question number 5, we're asked to consider the parallelepiped with edges defined by vectors u with components 5, negative 2, and 4, and v with components 1, 2, and negative 3, and w with components a and a and a. So we're asked for what positive value or values of a is the volume of the parallelepiped equal to 1. So you might recall that to find the volume of a parallelepiped determined by three-dimensional vectors, that what we do is we find the magnitude of the triple scalar product. So we need to take the cross product of two of the vectors and then take the dot product of the result with the third vector and then take the absolute value. Now, which two we take the cross product of doesn't really make any difference. It'll be okay either way. So if we want to do u cross v and then dot with w, that'll be okay. Or if we want to do v cross w and dot with u, that's okay. It'll all work out just fine no matter how we do it. So what we need is the magnitude of, let's say, u dot v cross w. Well, actually, it's not magnitude, it's just absolute value. Alright, so to find u dot v cross w, or whatever it is we're going to be using, we can do a 3x3 determinant. And so we would have 5, negative 2, 4, 1, 2, negative 3, and a. And as far as the order goes for these rows, any order will be just fine. You can swap up the order between any of these, you can reverse them. As long as you have one row that contains all A's, one row that contains 1, 2, negative 3, and one row that contains 5, negative 2, and 4, you're in good shape. Because we're going, all that would do is just change the sign SIGN, but we're going to be taking the absolute value anyway, so it'll all be okay. Alright, so in this case, we're going to get 5 times this 2x2 determinant. That's going to be 2a minus a negative 3a. I believe that's 2a plus 3a, which is 5a. Then you're going to get plus 2. Remember that when you go to this term, you need to change the sign, just like we did when we had the I, j, and k up there. So instead of being a negative 2, it'll be a positive 2. And now we need to multiply by that determinant, which is 1a minus a negative 3a. I believe that's 1a plus 3a, or 4a. And then finally, we need 4 times that 2x2 determinant, which is going to be 1a minus 2a, which I believe is negative 1a. So this is going to give us 25a plus 8a minus 4a, which is 29a. So that is the absolute value of that would be the volume of the parallelepiped that we're interested in. And we want the volume to be equal to 1, so we set this equal to 1 and solve for a. Well, I think it'll be alright if we just drop the absolute values and we say 29a equals 1. A is 1 over 29. And there's our answer. In, in question number 6, we're told to let u be the vector with components 7 and 16, and v be the vector with components 12 and 4. Find the magnitude of the vector a. Well, you've got this right angle right here, and so this is supposed to illustrate that a, the vector a, is really the projection of the vector u onto the vector v. So what we need to do is find the magnitude of this projection of u onto v. Well, you will remember that we talked about in section 11.3 that the magnitude of the projection of u onto v is equal to the it's equal to the vector u dot v over the magnitude of the vector v. Alright, so we need to take the dot product of u and v. So we multiply the x component, 7 times 12 is 84. We multiply the y components, 16 and times 4 is 64. Then we need to divide by the magnitude of v. So the magnitude of v is 144. We got that from squaring the 12, and then we need to add on the square of 4, which is 16. We'll add those and take the square root. This is 148 over the square root of 160. There's a perfect square in 160 that we can take out, so that would be the square root of 16 times the square root of 10. The square root of 16 is 4, and I believe 4 goes into 148 37 times. So that's 37 divided by the square root of 10. And in question 7, we are asked to find the component forms of the vectors a and b. So we know that we know the magnitude of the vector a, and so what we need to do is just multiply the magnitude, which we found was 37 over root 10, times a unit vector in the correct direction. Well, a and v are parallel, so the vector v is also pointing in the correct direction. So let's multiply by a unit vector in the direction of v. So we'll have the vector v divided by its magnitude, which we have already found was 4 root 10 from the previous problem. Alright, so we're going to have 37, and let's see, then we've got 10. Square root of 10 times the square root of 10 is 10 times 4. Now, I could go ahead and multiply the 4 together with the 10 and make 40, but notice that there's a common factor of 4 in each of these components, so I'm going to divide each of those components by 4, and that'll leave us 37 over 10 times 3 comma 1, I believe. So this is the same thing as what? Well, 37 times 3 is 111, and let's see, 37 times 1 is 37 divided by 10, so that would be 11.1 comma 3.7. I'm going to write that so that you can read it a little more easily. (11.1) and 3.7. Now, we also need to find the vector b. Well, we know that a plus b is equal to u. U is the resultant of adding a and b, or the resultant vector of a and b. So that tells us that the vector b is the vector u minus the vector a. Alright, so b then is going to be the vector u minus the vector a and that's going to be negative 4.1 comma 12.3, I believe.